Alright, there's that. Okay. Today we've got water polo. I still need a worker from 4 to 5 to commit to 4 to 5.
I get out of like the Oh yeah, I'll just swim after that.
Okay, that's fine. I just need hopefully somebody, whoever's working the first part. I think Jessica put herself on first.
Let's go with Jessica.
And then I still need somebody in the gym, because my person in the gym on the 7 to 8 hour is a question mark on that hour. He's staying for most of the rest. I need somebody in that kind of time. 7 to 8. Even if we could get to 7:30, that would get us partway through the last varsity game. Okay. There are
I wonder how you woke up like this.
So they do the freshmen on one day together at the same time. They stack the joy in varsity. So they hold one. It takes forever to get done. Okay. So it's a long afternoon. Okay. Alright. I just need to know somebody's gonna be there for somebody. And then so you guys know, I have to run my kids around kind of in the middle of it. But well, I'll be back. Because they have dance classes tonight. I got a grab. Alright, so this is nowhere to be written. We're just gonna kind of read through it together. Okay. So we've got the chain rule allows us to differentiate a wide variety of functions. We've talked about the chain rule because it's when we have that function embedded inside the other function, right? We're able to find the antiderivatives for only a limited range of functions, meaning we can only integrate at this point a very small amount of functions. Okay? Haven't been able to get very far. Alright? We can sometimes use substitution to rewrite the functions in a form that we can integrate. So we're going to kind of do the opposite of the chain rule today for integration. And that's what kind of today is about. And as far as integration goes, you guys, in AB, we just barely touch it. Okay? In BC, we don't even get through all of integration. Okay? When you go to college, and some of you are going to take Calc 3 or what they call multivariable calculus, we see multiple integration steps. Okay? So integration is a huge piece of calculus. Think about it. We're finding the area. It's also how we're going to find the volume of an object here in ultrasound. Okay? So integration is a huge thing, right? But you have to have extra tools to be able to integrate most functions. Okay? Like I said, we're going to touch the tip of it this year. Okay? All right. So some of this I kind of stole many years ago from somebody else, but he did a good job of setting up the use substitution. Okay? So what we're going to do is called use substitution. Now you notice my little purple sign up in the front. It's more for BC, but this is something if you can't integrate a function just the way it looks, that's the first place you go, is you look for a use substitution. And just like with the chain rule function, you're looking for a function inside of a function. So see how this x plus 2 is inside the fifth power? So that's a good setup for a use substitution. This one's a pretty simple one, okay? So we're gonna make it more complicated and interesting. So we're gonna let u equal x plus 2. You don't necessarily need to write the word let, but at least write u equals x plus 2. It's nice and typed on this first line. Okay? And animated. Yeah. Somebody spent a lot of time. Alright, now what I'm going to do is I'm going to take the derivative of this guy over here. So we're putting the derivative in with the integral right now. Okay? So, if we take the derivative of x, or we take the derivative of u, remember it's just du. Okay? What's the derivative of x? Yes, perfect. So we're going to, and the derivative of 2 is 0, right? So if the derivative of it is du equals dx. Okay, because I have to have something, if I'm going to substitute in for this, and I'm going to put a u in there, I can't leave my variable of integration as an x. I have to change out the dx as well. That's why I need the du. Okay, so now we're going to do our substitution in. We've been substituting for many years. So the u is going to go in for the x plus 2, so we get u to the fifth. Okay? And then the du goes in for the dx. We substitute that in for the dx. Okay, so all I did was I said that u was equal to x plus 2, right? So for the x plus 2 part of the equation, I put in the u. Okay? Then I can't leave it in dx's if I'm in u's, right? So when we took our derivative, we found that dx is equal to du, so for the dx part, I substituted in the du. Okay, now, this is super basic so far, so we want to make sure we get the basic. Okay? Alright, this is easier to integrate than that would have been, okay? So, we know how to integrate that, we've been doing that since before Christmas. What do I have to do? Add 1 and divide by my new exponent. So, we would have probably written it as u to the 6 over 6. It's the same as u to the, or 1/6 u to the 6, right? And then we put a plus e after it, a constant of integration. Today we're probably going to see more indefinite than we will see definite, right? Alright, then what you have to do is, because our original was an x's, we're going to put our x's back in. So I'm going to substitute what we had for u. I'm going to substitute back in the x plus 2. So don't forget to substitute the u back into the problem. So they took the u and they substituted it back in as an x plus 2. Okay? That was super slow and a super easy example. We're going to make it harder and harder as we go. Okay? Yeah. Can I explain this again? Okay, so we can't, because our original was an x's, I'll get your question. Okay, so my answer right now. Our original was an x's, we have to put our answer in x's. Okay? So in order to do that, we take our u that we had come up with was x plus 2, so I'm going to take the u that was here and replace it with x plus 2. Okay, so I substitute twice, right? I substituted my u and then I have to substitute my x. Okay. Again, this one was really simple. We're trying to simple so you get the process down, and then we're going to make it way more complicated because it would be something you really have to use substitution.
I did it for u plus x2.
Because it was inside the fifth power. So it was the inner function, like we would have in a chamber. Okay? Sure. Okay. Alright, let's do another one. We're gonna go slow again. Okay? This time the only little difference is we got that funky 5 out front, it's a coefficient, I'm just gonna leave it in front of my interval. No fancy animation on this one. Okay? Alright. Let's think like it was kind of the chain rule. We know we have to have the chain rule, we have to look for an inner function. So what's my inner function for my u? Perfect. And then over here we know we've got to take the derivative of it because I got to come in and replace the dx, I need a du. So what's the derivative of u?
du.
du. Perfect. What's the derivative of x? dx, and the derivative of 3 is?
0.
Perfect. Okay. So I already moved the 5 out front. What are we putting, substituting in the place of x plus 3? U, and it's u to the 4th. And then what gets substituted in the place of dx?
du.
Perfect. It's basically the same thing on this one, right? Alright, we're going to integrate like we've been doing. I've got a 5 hanging out front. U to the what power? Fifth, all over 5 plus 6. Perfect. Alright. I can do the over shirt. Everybody gets plus. Alright. That wouldn't work though because the left is confused. Alright, so what happens with the 5s? Cancel. Alright. In this same step, I'm going to go ahead and I'm not going to rewrite it. You do the 5th plus c and then sub in. Let's just sub in. So what am I subbing back in for the u part? X plus 3 plus 6. Okay. Tomorrow we're going to remember. You guys did ask me about solving for the c part, right? That comes up in tomorrow's stuff. Okay, so it's coming. Just not yet. All right. Example 3 is a little uglier, right?
Oh, yeah.
A lot uglier. All right. So part of finding. Well, first of all, we want to find the u. So I want to find the function that looks like an inner function. Okay. So if you just to blindly guess, what's the inside function?
X squared.
16 minus part of it. So what I'm really gonna do is I see these two pieces here, right? What I don't see is the -3. So I'm gonna move that -3 to the other side. Okay, so let's do that. You know, it goes slow. So when I divide that over, I would get -1/3 du equals x squared dx. Okay. Do we see how we have an x squared dx we have to substitute into? And we just solve for what x squared dx is. So in place of the x squared dx, I'm putting in the -1/3 du. Alright, so let me finish it, then I'll talk about it. Probably in this case here, I'm going to move this upstairs to integrate it. So u to the -2 du. Alright, when we integrate, what are we supposed to do?
Plus
Add what? So you get u to the
1
-1 divided by -1 plus c. Really, what's going to happen with my double negative? Positive. So, and then this u is not happy where he's at. We shift him back downstairs. So we have 1/u plus c. And then our final step is we have to sub back in for the u. So we've got 1/3 16 minus x cubed plus c. That's what I'm doing. So write it down, and then I want to explain one thing. We're all pretty Okay, so do you see how with this u substitution that when I took the derivative of this thing, especially the variable part of the derivative appeared in what they gave me originally? So if you see a piece of the function and its derivative sitting there, that's a great indicator you've got to use that. Right? You've got to do. Right? So you should see, and if you don't see the derivative there, you aren't getting the derivative, we've got to do something else. Okay? Maybe u sub isn't the plan. Right? Because there are, like I said, other types of integration beyond what we're doing for touching the plan. Okay? Alright, we're gonna keep going. Alright. So let's talk about this one. What's our inner function this time? 4x minus 1. Okay, so write that down for you. This one's animated. U equals 4x minus 1. You don't have to write the word let. Alright. And then what do we now do over here on the right side? Find the derivatives. Okay, what's the derivative of u? What's the derivative of 4x? 4 what after it? Dx, and then the derivative 1, 0, right? So we're writing down du equals 4 dx. Okay. We're going to go start substituting in. So I see the 4x minus 1, right? Do we have that 4 hanging out anywhere outside of the of that function? So that's an indicator I have the dx part, right? So I need to move this guy to the other side because it's not in my original. Okay? So how do we take that? It's being multiplied right now. How do we take it to the other side? Divide. So we always solve for the dx part. Divide that over. So I get 1/4 du equals dx. Typically, if it's a fraction, we'll see the 1/4 du instead of du over 4. Okay? All right. Instead of writing that as a radical, we probably convert it to the 1/2 power. Okay, that's what we're going to do in the next step. So what's going in for the 4x minus 1 piece? U 1/2 power. Okay? Alright. And then with the dx part, we're putting in the 1/4 du. This was the chunk that went in for the dx. Alright? We're really glad we have u substitution in this one. This one's not good. Okay. Alright. What am I supposed to do to integrate this piece right here? Add this is just a number, right? Coefficient front, we're just gonna leave it the way it is. Please.
Plus 2
Okay, so we got plus 2/2, so you get u to the what power? 3/2 times 2/3, right? And this guy here would have just been in front. The way this guy, whoever typed this, I mean, I would have probably put my own form in front. Style, right? Alright, do we see anything we can simplify right here? 2 into, well, this is the multiplication right here. How many times is 2 going to 4? 2. So it looks like I could multiply 2 times 3 and get 1/6 out front. So 1/6 u to the 3/2 plus c. Now I still need to sub back in for my u. What am I going to put back in for my u?
4x minus 1.
4x minus 1. Good. Alright. And then notice, if it's something that's not like it's a 1/2 or a 1/3, they will put back in the radical. If it's an improper fraction like that, they're not going to put it back in the radical. They're going to put it in the improper fraction. Okay? Alright, we got a couple more, right? We got a bunch more. Okay, let's keep going. The more we see, the better. Okay? Alright. Trig is always easy to tell the u. Okay? Whatever's inside the trig, right? Yeah. Same with u sub. It was always easy to tell a trig u sub. Alright, so what is your u going to be? Perfect. 7x plus 5. Okay. This one's actually basic for this last one. Alright, what's the derivative of u? du. What's the derivative of 7x? 7 what? dx, and the 5 goes away, right? Okay. I have the u piece. This is the u piece, right? I have the dx. What am I missing? Do I have that 7 hanging out anywhere as a coefficient? No, so I need to move that over to the other side. How do I move it to the other side? Divide. So we're really going to get 1/7 du equals dx. No. Alright, so I'm going to put in 7x plus 5, putting in u. For the dx, we're putting in 1/7 du. Alright, so there's where the substitutions were made. Anyways, the information is over here. This time you write a little bit nicer. Okay? This is a coefficient, right? That coefficient's going to go in the front. When we integrate cosine, what do we get? Sine. So we get 1/7 sine u plus c. Alright, and then what's going to get substituted back into the u? 7x plus 5. Yes. What's the derivative of u? Coefficient. This is like, I don't know. It's okay. We go, because here's the thing, you guys, it reverses. For some reason, once I teach integration, we lose all the simple stuff we learned right at the beginning, right? So, it happens.
Because of you, I forgot how to do the derivative.
Sorry. I don't know what it is. It happens every year. Okay? Alright, let's look at example 6. Okay? Alright. This guy's got a whole bunch of stuff on the H. This one's animated too. Okay? Alright. What do you think the U is going to be?
1 plus x squared.
Good. It's the inside function, right? Because the inner function is the inside that square root, right? Look at this right here. What's the derivative of that x squared? Do you see it sitting there? Okay, so that's a really good indicator. We've got to use some. All right, this guy's got some stuff here. So the derivative, blah, 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 blah. Okay, so here's his u. Just write this piece. U equals 1 plus x squared. All right, let's make sure we understand the simple piece here. Okay, good. Making sure. I don't need anybody lost on this part, okay? I want to make sure we got this part down, because tomorrow I'm gonna try to do a double lesson, okay?
Double lesson.
Alright, what, instead of writing, the square root, what are we gonna convert that to?
1
1/2 power, perfect. Okay, so what's gonna go in for the 1 plus x squared?
U.
The u, okay, and then what's gonna go in for the 2x dx part?
Du.
Du, perfect, and that's simple, right? So we literally got it down to u to the 1/2 u, which was way better than what we started with. Alright, even though we've got a fractional exponent, we can deal with that, that's not that bad. We're pretty good at 1/2 fractions, right? Alright, don't ask us to do like, half fraction. Alright, what are we adding?
2.
2 over 2. Okay, so when we add 2 over 2, what do we get as my new exponent? 3 halves divided by 3 halves and multiplied by. Sorry, it's good. Let's see. Alright. If, so what's going to go in for the u?
1 plus x squared.
1 plus x squared. So what's really fancy now, isn't it? Okay, but here's the catch. And I was trying to teach the process versus let's just make sure we've got it. If I did not have that 2x sitting there, I wouldn't have been able to do it. And with the u substitution, there could have been maybe some other way to integrate it. But there, I couldn't have used the u sub on it because I had to have the 2x there. Okay? There might be, and eventually I might be able to show you a way to kind of finagle the u a little bit to get it into use. But you've got to be able to substitute whatever's in your original has to be here. Okay? Somewhere to substitute it for. But if it appears here in the derivative, it better be in your original, or you've got to move it over to your side. Yes.
What if it like the 2x doesn't come out that
Your x is never going to be in front of your integral sign. Your 2 could be the yes, and the answer is yes. All right. That's why I just explained what that was. All right, let's do this one. All right. All right. So we got 3 more. All right. All right. What do you think u is going to be? Inside the trig, right? Whatever you're looking for that inner function. Okay, I like the x cubed. This one's animated. All right. What is the derivative of that?
U equals 3x dx.
3x
Squared.
squared. Yes. That x squared piece is important because look what's here. X squared there, right? Okay. What? I have an x squared and a dx. What am I missing? We got to divide by the 3, right? Because we don't have the 3 piece. So it's pretty common to have a coefficient like that that we've got to get to the other side. So 1/3 du equals x squared dx. Little note in here, you don't need full note. Solve for x squared dx. You can find it in the integrate. This is the integrate. Okay. All right, so let's sub in. What's going in for the x cubed? What's going in for the x squared dx?
1/3 du.
1/3 du, so that's what he's subbing in here. Okay. What's the integral of sine?
Negative cosine.
Negative cosine, very good. All right, and then what are you going to put in for the u part? X cubed. This isn't that bad. There's like 2 little extra steps compared to normal integration. All right? I know. Yeah, we're going to get some that are uglier probably at some point, but this today shouldn't be that. You guys have to tonight go home and do homework. Okay? You don't try to do old work. Do tonight's homework tonight. Okay? I know some people working about well, the day and downtime, so
Yeah,
I'll
I
be there
can't
to
do
help.
homework if I'm working.
All right. All right, so let's look at this one. I'm going to rewrite this one a little bit. This one's a little tougher to see. Remember, a 4th power can be rewritten as sine x to the 4th in the parentheses. inner function this time? Perfect, sin x. So u equals sin x. Alright. So let's see, derivative of u is du. What's the derivative of sin x? Cosine x dx. Isn't that handy? We have a cosine x dx in there. Okay, let's sub in what's going in for the sin x part.
You.
What's going in for the cosine x dx part? Perfect. That looks way better than it did before. I know I did it before. Alright, what do we have to do? Add line, you get what? Do the bend over 5 plus c. Alright, what am I going to substitute back in for the u? Sin x, and I typically I'll write it in the fancy way like they did in the beginning. So 1/5 sine 5x or sine 5x. Alright,
Only for the fifth x.
yeah. Alright, oh, this is a weird one. Okay? So we're gonna get one weird one out of the way. So this is something where we've got something goofy happening. Okay? We're gonna try to handle this. We've got a few minutes left to get this done. Okay? So we're gonna find the indefinite integral by the method shown in example 5. So what they're talking about is in the book's example 5. Okay? Those are probably the instructions in the homework. Okay, so when you get to that one, this is what we want to do. Alright, looking at what we've got there, what's our u going to be? 2x minus 1. Perfect. Okay? I'm going to go to the right this time with my du. So du equals what? 2 dx. I'm just going straight derivative. Okay, so I see this piece is the u, right? I see a dx. I don't see a 2. So I'm going to bring that 2 over as a 1/2 du equals dx. And I'm going to start substituting it. Okay? What am I going to rewrite this as?
2x minus 1.
1/2. Okay, so I'm going to go ahead. I know that that's going to, I already said I'm going to put u in for that, so that's going to be u to the 1/2. Notice I left a gap there. And then the dx part is 1/2 du. Please do I not take it?
Yeah.
I haven't doubled that because it didn't show up here, right? Now, had it been, if it's just an x, I think I can get a u somehow out of that, okay? If it was an x squared, I might have a little bit more trouble and it not be possible, okay? I'm not going to give you something that you can't do at this point, okay? So, do you see this guy right here?
I do.
Couldn't I solve that for x?
Yes.
And then I would know what to substitute in for an x in terms of u. Okay, so what are we going to do to move the 1? Got it. I had to have left a space underneath there for some reason, right? Okay. What do I need to do with the 2? Divide it. Good. So that's going to go right in front here as u plus 1 over 2. Okay. We're going to do some algebra. Okay, I'm going to clean this up a couple steps before I integrate it. Couldn't I take that 2 and move it out front with the other 2? So in front I'm going to have 1/4. And this is really, now I've got u plus 1 times u to the 1/2 du. We don't have product rule for integrals. Okay, so I don't have something like that that I can do just now. What is instinct probably take over until I do here? Let's distribute first. Okay? Remember, this is like saying 2 over 2. So I have 1/4 u to the what power? 2 divided by 3 over 2 or multiplied by. Yeah, I always do that gap when I've done the fractional. I know that happens, something like that. Okay. Let's see. And at this point, what's the last thing we need to do? Substitute. I'm not worried about distributing that one form. If I was looking at something that was multiple choice, and I saw in my multiple choice answer that it's distributed, I will distribute it. I'm probably not going to do that. Okay? So you put back in the 2x minus 1 to the 5 halves plus 2/3, 2x minus 1 to the 3 halves plus 0. Okay? Alright. I need to move your notebook over here real quick. I'll do that right now. You guys, make sure when you're using the turtle books and you're putting them away that you plug it in.
Yeah.
There were a lot dead yesterday. Really. I think it was because we may have had a power outage, and I needed to reset the card. But please, please, please make sure you plug in. And if you can work it all day, or you said you could come in for partnership, can you put that on the Google Doc for me and put the time you're going to start? Okay, this is part patronship, so we know who's looking for it. Okay. Alright, so the assignment was just copied over to the page. You should have a homework assignment up there now. Okay? You guys can go. Thank you for staying the extra couple minutes to get through that. Okay?
Thank you for showing us the